Hello, grade 9 learners. In this video, we'll just continue from the part 1 of the video that has been already uploaded. So we have already looked at what the gradient is, what y-intercept is. We have already looked at the standard form of different straight line equations. Okay, and we all know that the standard form is y is equal to mx plus c, where m is your gradient and c is the y-intercept. Okay, so in the following examples, we'll just look at how we can determine the equation by, for instance, if we look at 4.1, if we're given the gradient and the y-intercept. So let's determine the equation given the gradient, which is m equal to 3, and an intercept, a y-intercept with this point. Remember, if it's a y-intercept, it means that it's cutting or it's intersecting the y-axis. Okay, so this is the point that we have. Now, we know that in standard form, this is how we write the equation of a line. It's always y is equal to mx plus c. Okay, now let's write the equation from the information given. So which means that y is equal to, in place of m, what do we put? Put 3, because we're given m as 3x minus, in place of c, we put the value of y for where the line is cutting the y-axis, which is minus 3. So that's why we have minus 3 there. Okay. If we look at the second example, where you're given y-intercept and the point. Okay, so you're told that your line, your straight line cuts at 5, positive 5, right? And you're given just a point that is along the straight line. So it's a point that's somewhere along the straight line. All right. And remember always that the standard form for a straight line is y is equal to mx plus c. Okay, so what do we know from that equation so far? We know that the y-intercept is 5, right? That's why we have plus 5 there. Okay, so now we need to calculate what m is, all right? So from this equation here and the point that we are given, we can easily calculate what m is, because with the point that we're given, we are told that x is equal to 1 and y is equal to 2. Okay, so we go back to the equation and just substitute in our point. All right, that's why we have 2, which is equal to y is equal to m times 1, which is equal to x, plus our y-intercept, which is 5. All right. Now, if we further simplify this by making m the subject of the formula, all right, it becomes m is equal to 2 minus 5. Okay, all we did is move plus 5 to the other side of the equation, and remember it changes sign whenever it crosses over. All right, so we're left with minus 3 on the right hand side if we simplify the right hand side. All right, so now we have our m being equal to minus 3. So we can go back to the standard form equation, and in place of m, we just put minus 3. Okay, so our equation for the straight line is just y is equal to minus 3x plus 5. Okay, now if we look at this example here where you are given the gradient this time and a point. Okay, so how do we determine the equation? Given the gradient and a point. Okay, first thing that you always have to do is write down your standard form equation, which is always y is equal to mx plus c. All right, now we know that m, which is always our gradient, is minus 2 from what we're given. So we can simply substitute in our value just like how it has been done here. So y is equal to minus 2 because that's the value of m times x plus c. Okay, so now we need to find what c is. Remember, c is the y-intercept, so we need to find the value of c. Okay, it's easy to do that because you have a point, all right? So you can easily substitute in the value of y as 1 and the value of x as 3. Okay, so now when you do that, if you look at here, substitute the point, y is 1 is equal to minus 2 times x, and x is 3. That's why we have a 3 there, plus c, which is the unknown. We don't know it. Okay, so we have an equation there. We need to solve for c. Okay, so if we simplify this first step here, it becomes 1 is equal to minus 6 plus c. Okay, now to solve for c, make c the subject of the formula and move minus 6 to the other side of the equation, and it becomes positive 6, right? Which means it's going to be 1 plus 6, which gives us 7. All right. So we know our y-intercept now. Our straight line is cutting at y is equal to 7. All right. So now we can write our final answer. So our equation for the line would be y is equal to minus 2x plus 7. Okay. Okay, let's say now you're given only 2 points and you're asked to determine the equation of the straight line. Okay, so when you're given 2 points like this, all right, the first thing that you need to do is calculate the gradient of that line. Okay, so how you do it, because remember from your notes, you know that gradient is defined as the change in y over the change in x. Okay, so we need to know what y2 is, y1 is, x2, x1. All right, so the easiest way to go about it is to label your points like this. So minus 1 is x1. Okay, all right, and 2 is y1. All right, for this point here, 3 is x2, okay, and 4 is y2. Okay, the reason why we're using these, we call them subscripts, there's numbers here at the bottom of the variables, is because we're trying to show you that we have 2 x values and 2 y values. That's why we differentiate them in that manner, right? We have the first x value, which is minus 1, with its corresponding y value, which is 2. Okay, we have the second x value, which is 3, with its corresponding y value, which is 4. So don't get confused. All right, so now let's go back to this equation now and substitute in our values, since we know what y2, y1, x2, x1 is. Okay, now when we do that, y2, we know it's 4. There we go. y1, we know it's 2. There we put 2. Then x2 is 3. That's why we have 3 down there. And x1 is minus 1. That's why we have minus 1 there. Okay, so now when you simplify this piece, this becomes, if you look at the numerator, 4 minus 2 is just 2. Okay, 3 minus -1. Okay, remember, if you have an operation which is negative followed by another negative, negative followed by negative gives you a positive. So 3 minus -1 is equal to 4. It's the same as saying 3 plus 1 is equal to 4. Okay, when we further simplify this, you get a half. Okay, so now we know what our gradient is. We are sorted, so we know what m is. Okay, now remember, if you go back to the standard form, which is this here, y is equal to mx plus c. Okay, we can easily substitute in our m value because we have already calculated it and we know it's a half. Okay, so now in this step here that you see here, it's just us substituting in our m value, which is half. Okay, so now there's something missing for us to complete our equation for the straight line. What is missing? It's the y-intercept, which is c. Now, how do we go about that? Remember, we're given 2 points, right? So what you do to calculate c is substitute any point, either this one or that one. Okay, so in this case, they chose 3, 4. All right, so you go back to your equation, you substitute in, we know that y is 4, that's why we have 4 there, and we know that x is 3, that's why we have 3 there. Okay, plus c, and this is what we want to calculate. Okay, now let's further simplify this equation. You get 4 is equal to, if you multiply this 2 here, half times 3, you get 3 over 2 plus c. Now, how do we calculate the value of c? You make c the subject of the formula by just rearranging your equation. And how do you do that? You move 3 over 2 to the other side of the equation, and it becomes minus 3 over 2. All right. But we know that minus 3 over 2 is an improper fraction. It's just minus 1.5. Okay, this is where the 1.5 is coming from. It's just you converting to a mixed fraction. So from improper fraction to a mixed fraction. All right. Now, when you do this, if you subtract these two values here, 4 minus 1.5, okay, you should get 2.5. Right. So now you have your c value, which is the y-intercept. You can go back to your equation and write the equation of the straight line in a standard form, which is y is equal to half. Remember, half is the gradient, x plus your y-intercept, which is 2.5. So that's how you go about these problems when you're asked to determine the equation of a straight line in standard form. Okay. Now, there's one thing that I want to mention, okay, before I carry on with the other examples. Okay. So sometimes you are given maybe 2 lines like this. Okay. 2 lines that are parallel to each other. Okay. If you know the equation of the first line, okay, that is, you know, the slope or the gradient of the first line, right? If the two are parallel, if the 2 lines are parallel, this means that the gradient of the second line is also the same. So take note of that. Gradient of the first line is equal to gradient of the second line. That is if the 2 lines are parallel. Now, sometimes you get lines that are perpendicular to each other. That is, they form where they meet, they form a 90-degree angle, right? So you have line 1 and line 2. All right. And all the time, if you want to prove that the two lines are perpendicular, when you multiply the gradient of the first line times the gradient of the second line, you should get -1. So the product of the two slopes should give you -1. That is if the two lines are perpendicular. Okay. All right. Okay, let's move on with more examples. Okay, determine the variable if the point lies on a line. All right, so we are told that a point P1 lies on y is equal to 2x plus 1. Determine P. Okay, so the first thing that you need to do now is substitute your point into the equation. Right, substitute it as it is. So we know that x from our equation is P. There we go, right? And we know that y is 1 from the point that we are given, right? So now we have an equation in terms of P. 1 is equal to 2P plus 1, right? Now we can easily solve for P by rearranging our equation, make 2P the subject of the formula by moving plus 1 on the other side to the other side of the equation, sorry, which becomes 1 minus 1, which then gives you a 0. All right, so you're left with 2P, which is equal to 0, and P is just 0. All right, so you've determined the variable P. Okay, let's do this example here, which says determine whether a point lies on a line. Okay, so we're given a point 2, 1, which lies on a line. All right, and we're given the equation of the straight line. Okay, how do we then do that? How do we prove that this point lies on a line? All right, so what you do is, because we know that x is equal to 2, right? You need to substitute in the value of x into your equation. Okay, when you do that, you want to see what y value you will get. You want to know the corresponding y value that you're going to get, right? So the corresponding y value that you're going to get should be this one here. It should be 1. Okay, so you take the x value, you put it into the equation to see what y value you get. Okay, so let's do that. So in this second step here, we have, because we know x is 2, so it's going to be a half times 2 plus 2, which is -1 plus 2, and it gives you 1 as your y value, right? Which corresponds to the point that we given there. Therefore, this point lies on the line. All right. Okay. Now let's use this concept here that I explained earlier on. Okay, let's use it to try and answer these following questions. Okay, so now determine P if you have an equation of y is equal to px plus 2, which is parallel to 2x plus y is equal to 5. Okay, so the first equation that you have is y is equal to px, okay, plus 2. And they want you to determine the value of p. the second equation of the straight line, and they are telling you that it's parallel, is okay, it is 2x plus y is equal to 5. Okay, so from this equation, you can see that the equation is not in its standard form. So you need to convert that to standard form. Okay, so how do you do that? Remember, standard form is always y is equal to mx plus c. Okay, so we need to make y the subject of the formula from this equation here. So it becomes, from that equation, go down here, it becomes y is equal to y is equal to minus 2x plus 5. Okay, how did I do that? I just moved 2x to the other side of the equation and it becomes minus 2x. Okay, so now it is in its standard form. Okay, remember I said if two lines are parallel, which means they have equal gradients. Okay, so this is line 1 and this is line 2. Okay, that's line 2. So gradient of line 1 is equal to P. Gradient of line 2 is equal to, remember, this is your gradient here, is equal to minus 2. And if the two lines are parallel, okay, if the two lines, if line 1 is parallel to line 2, it means that M1 is equal to M2, all right, which means P is also minus 2, all right. All right, let's look at the second question. It says, determine whether the following lines are perpendicular to each other or not. Okay, what lines are we given? Okay, we're given y is equal to 3x minus 1 and 4x plus 3y is equal to 6. So line 1 is already in standard form, as you can see, but line 2 is not. Okay, so we need to make sure that line 2 is also written in standard form. So how do we do that? So we have 4x plus 3y, okay, is equal to 6. Now we need to make 3y the subject of the formula. How do you do that? 3y is equal to, move 4x to this other side of the equation, it becomes minus 4x, okay, plus 6. All right. Now remember, we want to make y the subject of the formula. Remember the standard form. Okay. So how do you do that? You divide both sides of the equation by 3. Okay. Which means on the left hand side, you're left with just y. And on the right hand side, you're left with minus 4/3 times x plus 6 over 3, which is just 2. Okay, let's just put 2 there. Okay, which is just 2. All right. Now we have the equation in standard form. Okay, so if you look at line 1, right, M1 is equal to 3/4. Okay, if you look at line 2, M2 is equal to, we've just put it in standard form there, it's equal to minus 4/3. All right, remember what I said about perpendicular lines. If we go back, the gradient of the first line times the gradient of the second line should give you -1. So the product of the two slopes should give you -1 to prove that, or to show that the two are perpendicular. So M1 times M2 should be equal to -1. So let's multiply this 2 3/4 times -4/3 is equal to -1. Okay, therefore the lines are perpendicular to each other. All right.